All right, 2.5, converting between radical and rational exponent forms. So on the left you have rational form, which is something taken to an exponent, a fractional exponent, and radical form is with a radical, be it a square root, cube root, whatever, okay? These are interchangeable. You can convert back and forth between the two. And it's really simple. The numerator goes on the outside, and the denominator goes on the outside. The numerator goes here, okay? So in practice, you'll see how easy it is. So here we have the fourth root of 7 squared, which is really just 49, but 7 squared, we're writing it that way. So we're just going to rewrite that as 7 to the 2/4, which can also be written as 7 to the 1/2, simplified. Okay, 2/4, 1/2, same thing. So it's really just saying the fourth root of 7 squared, which is 49. Okay. Here we have x to the 5/3. All right. So again, if you look up here, the index number right here is our denominator. Okay. So the index number is always the denominator. So here we don't see an index number, but remember, when we don't see one, then we know it is always a 2. And the x doesn't have anything, but it's really 1. Now, we got to be careful here. The 3x in its entirety is underneath the radical, so we have to say 3x in parentheses to the 1/2, because the entire 3x is underneath. If we wrote it this way, okay, then only the x would be under the radical, like so. Right? It's a very important distinction. What the entirety of what's underneath the radical needs to be put in parentheses and raised to that exponent. Okay? So just notice the difference between these two. It's very important. All right? Notice in this one, the 7's on the outside. So when we put the y to the 2/3, that only goes with the y. Okay? Now going the other way. So we write this, we put the 5 underneath. Okay? Remember, the denominator goes outside, and this is 5 squared. X to the 1/4, so the x is going to be underneath. The denominator goes here, and we can put the 1 or not, it's okay. Now notice here on this one, we have the entire 2y in parentheses, so the entire 2y goes here. Okay? And the denominator, 3/2, so that goes right there. And that is cubed. That's a 2y cubed. Now, very important here, again, notice the z is the only thing with the fraction, so the negative a is going to be on the outside of our radical. The denominator is our index number, and then z squared. Right, negative power reminder. If your power is negative, what is it going to do to your base? Okay, so think about it. X to the -1 is the same thing as 1 over x. So this entire x goes downstairs to the basement. So 2x to the -1/4. Well, let's step back and do 2x to the 1/4. Okay, that would simply be the entirety of the 2x here, like so. But when it's negative, all that is, it's the exact same thing. We're going to take the same thing and just put it down here. That's the only difference. The negative exponent just moves it downstairs. So we evaluate it the same way. We rewrite it the same way. Okay? We just put it down underneath 1. That's it. Okay. So 8 to the 1/3. So 8 is going to go here, and that's basically a cube root. And then using our chart, the cube root of 8 is 2. Okay? 81 to the 3/4. Now, there's two ways to go about doing this. You can cube the 81 and then take the 4th root of that, okay? Or you can take the 4th root of 81 first. I like to do it that way, and you have smaller numbers. So the 4th root of 81 is 3. And then I would just do 3 cubed, which is 27. Again, I could have done it the other way, okay? I could have done 81 cubed. So 81 to the 3rd power, okay? And then found the 4th root of that. But that is harder to do, whoops, sorry. That is harder to do on using the chart because it would take a while to break this down. Oop, I missed a number there, sorry. My bad. 5, 3, 1, 4, 4, 1. There you go, 27. So I prefer to take the root first, get it smaller, and then put it back up. But it's up to you which way you do it. Okay, 36 to the negative 3/2. So first off, I'm going to move down a little bit. I'm just going to put 36, or 32 evidently, because, you know, writing is hard. 36 to the 3/2. Okay? And then to make it negative, I just do this. And now I'm just going to deal with it. So the square root of 36 is 6. Okay? And then 6 cubed is 216. So this is simply 1 over 216. Now remember, all I did was I looked at my chart. I took the square root of 36, which is 6, and then I cubed it, which is 216. And I put it on the bottom because it's a negative exponent. Now this one, there's two ways of writing this. You can do it this way, or you can do it separately. Doesn't really matter. It's the same thing. These are equivalent. But basically, it's the square root. So it's the square root of 4, which is 2, over the square root of 25, which is 5, and that's it. All right, now properties of exponent rules. We've talked about this before, and do it again. If you multiply two terms that have the same base, you add the exponents. So for example, x to the 3, x to the 4, x to the 7. Now using that same idea, we're going to do this. So we're going to multiply 3 times 5 and you get 15. X squared and x to the 3 is going to be x to the 5. Y to the 4th, y squared is going to be y to the 6th. And that's it. Now quotient, you subtract. Okay? But I like to reword this myself because when you subtract, sometimes it's okay, but sometimes in the second one, it leads to a negative number, and then you have to move the negative number. I like to just say, where do I have more of them and how many? So for number 14, example 14, where do I have more? On top. How many more? 5. Okay? On the next one, where do I have more? On the bottom. So I need a 1 there. How many more? 7. Now, technically, if you did the subtraction thing, you would get x to the negative 7. And then you'd have to remember to move it downstairs. So I personally just like to say, where do I have more? And that's where my answer is going to be. Okay? So this throws people off. Just look at the numbers first. Like a regular old fraction from grade school, you're going to reduce. What goes into 24 and 18? The biggest number. 2 goes in, 3 goes in, but so does 6. So 6 goes in 4 times and 3 times. That's the fraction simplified. Now the letters. Where do I have more x's? On the top. How many more? 1. Where do I have more y's? Again, on the top. How many more? 5. Or I could have done 5 minus 4 and 6 minus 1. Same thing. But I like to do it the other way just to avoid negatives and having to remember to move them. All right, power. When you raise a power to another power, you multiply. So this is going to be x squared to the fourth is x to the eighth. And the reason that is because we really have this 4 times. Well, with the previous rule, when we're multiplying, we add the bases, 2, 4, 6, 8. There we go. Now we're going to apply it. Remember, this 3 also goes to this 1 that's not written. So it's going to go here, here, and here. So first we're going to get 4 to the third. This right there is the most common mistake, is forgetting that right there. Most people will do 3 times 3 is 9, and 2 times 3 is 6, but they forget this right here. Also, since you have a calculator, you should do this either in your head or on the calculator. 4 times 4 times 4, or you can look at your chart for this one. 4 cubed is 64. So this would simplify to 64, x to the 9th, y to the 6th. And that'd be our answer. And then fractions, same thing. I'm going to look at my numbers first. Okay, 12 over 26. Okay, 2 goes into both of them. 6 times and 13 times, and that's it. Because 13 is prime. Now, I look at my letters. And again, I'm going to use a little trick. Where do I have more x's? On top. How many more? 3 more. Now, a little tricky here. I can't have these, so I need to move these up here with that y to the 1. So technically I am going to subtract. And I'm going to do 1 minus negative 2, which is 1 plus 2. So I'm going to get the 3 anyway. But otherwise, I like to think of it as just moving them upstairs. And then the z's, well, look what happens there. I have 5 and 5. I'm done. They cancel. Technically, 5 minus 5 is 0. Anything to the 0 power is 1. All right, last one, kind of putting a few things together. First off, I need to simplify this one. So I need to send the 3 in there, there, and there. So my 4x cubed y squared is just going to stay. Then I'm going to have 2 to the third power. I'm just going to change that to an 8 right now. But technically that is 2 to the third. I just skipped a step. And I'm going to have x squared times 3. 2 times 3 is 6. And then negative 5 times 3 is, it's a y. Negative 15. Now I'm just going to clean it up. So 4 times 8 is 32. X to the 3, x to the 6 is going to be x to the 9. 2 and negative 15 is going to be negative 13. And then I'm just going to move those down here and get 32 x to the 9 over y to the 13. Now, another way to do that was I could have moved these down here and then said, where do I have more on the bottom? How many more? 13. But it doesn't matter. Your choice of how you get there, just a different route. And that's my answer. And actually, that is the end of the notes.